start by briefly discussing all the steps of the algorithm, then we will delve into each step in detail. Steps. The first step is initialize. We initialize the required variables. A map char index to store the last index of each character. Max length to keep track of the longest substring found. Start that represents the starting index of the current substring. Next, we need to iterate through the string character by character. For each character, check if the character repeated within the current substring. If yes, update start to be 1 past the last index. After that, add the current character and its index to the char index map. Calculate the length of the current substring. Check if the current substring length is greater than the current max length. Update max length is yes. And in the last, return the max length, which represents the length of the longest substring without repeated characters. Now, let's break down each step of the algorithm in detail. The top step of the algorithm is initializing variables, char index. This map stores the last index of each character encountered in the string. It helps to efficiently determine if a character has already been seen and update the starting index of the current substring if necessary. Let's debug a LeetCode to make it more clear. Step 1. The map adds the key A with a value of 0. Step 2. The map is updated to include the key B with a value of 1. Upon encountering the new symbol C, the corresponding key is added to the map with a value of 2. Step 4. The value of the key A is updated to 3, and so on. Max length. This variable keeps track of the maximum length of the substring. Start. This variable represents the starting index of the current substring being considered. It moves forward whenever a repeating character is encountered. Discarded the character before it from the current substring. Step 1. Start is initialized to 0. Step 2 and 3. New characters B and C are encountered and added to the char index map. Since they have not been seen before, the start remains at 0. Step 4. The character A is encountered again, so we update our start and consider as the longest substring BCA. Let's start iterating through our string. The is the character repeated within the current substring condition is the key part of the algorithm. Let's break it down in details. The first criteria is search for repeating characters. Determine if the current character has been encountered previously within the current substring. Retrieve last occurrence. If the character is found within the substring, retrieve the index of its last occurrence. Check conditions. Confirm that the character exists within the substring and that its last occurrence index is greater than or equal to the starting index of the current substring. And the last one, update start index. If both conditions are met, update the starting index of the current substring to exclude the previous occurrence of the character. Let's debug it a little to understand all conditions. I will start within step 3. Char. The current character being evaluated is C. Last index, the C has not occurred before in the substring. Found. The value of found is false, indicating that C has not been encountered in the substring before. Start. The start index of the current substring is not changed. In step 4, we recognize the need to update the start index. Let's examine in more detail how we interpret this change. Char. The current character being evaluated is A. Last index. The index of the last occurrence of A is 0. Found. The value is found as true, indicated that A has been encountered before in the substring. Start. The starting index of the current substring is 1. This is updated because the last occurrence of R is found and at index 0. So we need to shift the start index to 1 to exclude the previous occurrence. In the next step, we add the current characters and its index to the char index map. This was demonstrated in the previous step. For iteration 3, we added the character C. For iteration 4, we updated the index for character A, and so on. Calculate the length of the current substring. Let's break down the expression. I minus start. This calculates the distances between the current index I and the starting index of the current substring. This difference gives us the length of the current substring excluding start itself. Plus 1, we add 1 to account for the starting character of the substring. So, length equal I minus start plus 1 calculates the length of the current substring by taking the difference between the current index and the starting index of the substrings and adding 1 to account for the inclusive length. Let's proceed with the last step of iteration. Check if the current substring length is greater than the current max length. And update max length is yes. I think that this condition is quite obvious from the description, and there is no point in commenting on it. Actually, this iteration through the string allows us to find the maximum substring without repeating characters. That's all. Let's code it. I prepare test data in advance, ensuring that we can thoroughly validate the algorithm. Furthermore, I have outlined steps derived from the algorithm to provide clarity. Let's code it. The first step is initialize the variables. Char index map with key integer and value of byte, max length, and start. Next, iterate over each character in the input string. Check if the current character has been encoded before, and update the start index. Next, update the last index of S in character index map to the current index I, and calculate the length of the current substring. If the length of the current substring is greater than the current max length, update max length with the new length. And return the final max length as a result. Let's start our program to debug it. Case 1. With the first input we have 3 as the max length. For the case 2 we have 2 as the max length. And for the case 3 we have max length 3 as well. Through this case, we will ensure that the algorithm behaves as expected under various scenarios, and let's validate it on LeetCode. Upload the provided code to the LeetCode. I will execute several test cases on the platform to confirm the accuracy of the algorithm. Yeah, it's working.